The AML Dashboard is an open-source tool that simplifies working with the AML framework. It helps researchers and computer scientists train, evaluate, and deploy AML models more easily. The dashboard brings together the AML engine, AML IP, the DDS router, and the fast DDS monitor in one unified interface, supporting the entire workflow developed within the ALMA project. We begin by collecting data. This can be done using standard datasets like NIST, uploading a custom dataset, or creating one by recording gesture data. Once the dataset is selected, we move on to creating an AML IP computing node. Then, we head to the training interface, set the parameters, and start training the model. Here, we can see what's happening in the backend during training. The main node sends the data to the computing node we created, which is responsible for managing the training process. Once training finishes, the dashboard downloads the model automatically. Now we'll train a neural network model to compare with the AML model. Instead of training from scratch, we can fetch a pre-trained model using the dashboard's fetch feature, starting with a sender node. After setting up the sender, the dashboard fetches any new model or stats automatically. In the backend, we have a model manager sender node, created through the dashboard, and a model manager receiver node. The sender node publishes the model statistics to the receiver. If the receiver identifies it as the desired model, it sends a request, and the sender responds by providing the model. Now, we want to evaluate our model's performance. We'll start by creating an inference node, and then run a batch prediction, which will return a confusion matrix. In the backend, we can see our AML IP inference node along with an edge node, which is part of the server. The edge node sends an inference request to the inference node, which processes it and returns the result. After receiving all the inferences, we'll repeat the process for the neural network model to compare the results. Since we're using live-recorded gestures, we can also perform real-time prediction. This will show which class the just-performed gesture belongs to. Behind the scenes, real-time prediction follows the same process as batch prediction. We now stop the camera used for real-time prediction and move on to the context broker. First, we configure all the server parameters and create a fireware node, which is integrated into AML IP. In the backend, we can see that the node has been successfully created. With the node created and the context broker available, we upload an image by dragging it into the interface to perform an inference. In the backend, the image is posted to the context broker. At the same time, an edge node integrated within the fireware node sends the image to an inference node for categorization. Once the inference is complete, the AML dashboard displays the results. The AML dashboard also allows us to create and destroy AML IP agent nodes of any type, server, client, or repeater. This feature is part of the DDS router integration in AML IP, enabling seamless WAN communication between nodes. Finally, for debugging purposes, the AML dashboard includes a status interface. Here, all available nodes display their current status, helping ensure everything runs smoothly. eProsima also provides the fast DDS monitor, a tool that offers detailed insights into DDS domains and a visual overview of the network's architecture.